Hello, boys and girls. Welcome back to another edition of Crush Lusher Television. All right, we are going to do this free response from the 2000 test, number 5. So number 5 means we do not use a calculator. All right, this is implicit differentiation. So this is a throwback kind of one. So if you do not know, go back and look up implicit differentiation about how to do it. And if you get stuck, look at the video and see how you can fix it. So right now I want you to see if you can do A, B, and C as best as you can without any help. Then press play and see where you at. Ready? Or you can do A and then press play, or B and then press play, or C and then press play, and then do step by step. Whatever you prefer to make sure you learn it the best, because this may be on the AP. We don't know. Let's check it out. Here we go. All right, first one. We got xy squared minus x to the third y equals 6. And we got to show that the derivative is this, so I have to derive this. Well, what the hell is this right here? Well, that is, I put in Desmos. This is a non-calculator one, but I put in Desmos anyway, whatever. So this right here looks like there's a parabola, has this curve and this curve, so all sorts of funky stuff going on. So this is what it looks like. Now let's analyze it using some calculus. So if I'm finding the derivative of this, I need to do the product rule twice. So that would be write down the first, derivative of the second. Derivative of y squared is 2y dy dx, plus write down the second, y squared, derivative of the first. Derivative of x is 1. Cool. Minus, so now I'm going to do the product rule again with this part right here. I'm going to put it in brackets because I have to distribute that negative later. So write down the first, x to the third. Derivative of the second, derivative of y is dy dx, 1 dy dx. Plus, write down the second, y. And then derivative of the first, derivative of x to the third is 3x squared. So you see that one? Equals, running out of room here. What's the derivative of 6? Yeah, that would be 0. Derivative of every constant is 0 because the slope is 0. All right, so let's clean this thing up. So we got 2xy dy dx plus y squared. Let's distribute this negative, shall we? So we got minus x to the third dy dx minus 3x squared y equals nothing. All right, there we go. So now what do we have? Oh, it looks like we have some dy dx terms and we have some non-dy dx terms. So let's solve for dy dx. I'm going to get everything else the hell out of here. So y minus y squared and then plus 3x squared y plus 3x squared y. Alright, so now I'm left with just the dy dx terms on the left. So 2xy dy dx minus x to the third dy dx equals 3x squared y minus y squared. Why did I put it that way? Because it's that way in the derivative. I'm trying to get this. This is my goal. They sort of give you a little gift. So now I need to factor out a dy dx because that's what it has on both sides, both terms, sorry. 2xy minus x to the third, because I took one out of each, because if you distribute, you get the same thing back, equals 3x squared y minus y squared. Cool. Last step, opposite of multiplying by dy dx is dividing. Hello. 2xy minus x to the third. Whoop. And that looks like this, ladies and germs. There we go. So we good? No. First one, thank you very much. Give me my points. Now let's go to B. What does B say? I don't remember, so I'm going to go look. Let's read the question, shall we? Find all points in the curve where the x-coordinate is 1 and write an equation for the tangent line at each of these points. All right, so a lot of stuff to do. Let's get to it. Boom. So if I'm looking at the graph here, so what the hell is going on? So it says find all the points whose x-coordinate is 1. So that means there might be more than 1. So look at this. X-coordinate would be 1. So this is 0 and 2. So 1 is here. So here's 1. Boom. And then here's one down here. Boom. So it looks like these 2 points. So there's 2 points, one here and one here. So 1, 3, and then this. So there's 2 points where the x-coordinate is 1. So, and then we need to find the tangent line of those. Okay. So boom. Let's do it. So this is the actual curve right here. So if I want where the x-coordinate equals 1, I'm just going to plug in 1 to the original coordinate. I'm not talking about the slope just yet. I just want to know the x is 1, what was the y? So I'm going to go 1y squared minus 1 to the third power y equals 6, which is y squared minus y equals 6. Ooh, I see some factoring in our future. So every time we factor, we have a polynomial we said equal to 0, and then we factor. Negative 3 and 2, so y minus 3, y plus 2 equals nothing. Zero product property, what minus 3 is 0, that would be 3. What plus 2 is 0, that would be negative 2. Bam. And so my 2 pointy points, 1, 3, because 1 for the x, 3 for the y, and 1, negative 2. Boom. Nice. Okay. So now we have the x and the y. Now I need to know the tangent line of both of those points. Remember back from the graph, that looks like the tangent line was 0, but let's just prove it anyway, because we don't get that luxury of looking at the picture necessarily. We just have to do it through calculus. So we know that our slope is this thing right here, or this. Same thing, we got it there. So my slope, I'm going to plug this for x, this for y. So I'm going to get dy dx. My slope of this point, I'm going to do it twice. I'm going to do it again for this. But I'm just going to do it for this one right now. Equals 3 times 1 squared times 3 minus 3 squared over 2 times 1 times 3 minus 1 to the third. Cool. This is 3 times 3, which is 9 minus 9. Over 6 minus 1, which is 0 over 5, which is 0. Boom. All right, first tangent line. Let's do it. Y minus 3 equals 0 times the quantity x minus 1. There you go. And you can simplify that if you want to y equals 3. But this is also an acceptable answer because you don't have to simplify necessarily when you're doing free response. All right, now next one, dy dx, second point. Because there's a second point here on the graph. So I'm looking here, so this is 1, so there's got to be a positive slope. So it sort of looks something like that. Okie dokie. Boop. Oh, sorry, I need to go to this. Boop. All right, dy dx equals, plugging in here again, same thing. 1 for x, negative 2 for y. So I have 3 times 1 squared times negative 2 minus negative 2 squared over 2 times 1 times negative 2 minus 1 to the third power. Cool. All right, what does this get us? I don't even know. 3 times negative 2 is negative 6 minus negative 2 squared is 4. Okay. And this is 2 times negative 2, which is negative 4 minus 1. Okay, so what do we have? We got boop, boop, negative 10 divided by negative 5, which is 2. Okay, so that's my slope. I looked at the graph, it was a positive slope, so it looks reasonable. So we got y plus 2, here's my tangent line, equals 2, my slope times the quantity, x minus 1, boom. There we go. So here's my 2 points where x equals 1. Here are my 2 tangent lines. Boom, give me my points. Check plus for Mr. Irish. There we go. Let's go to C. Not done yet. C is always the most challenging part. Let's see what it has in store for us. Find the x-coordinate of each point on the curve where the tangent line is vertical. Okay, tangent line is vertical. What the hell does that mean? Well, we got tangent line here. Tangent line is vertical. That means the slope is undefined. So the slope is undefined. That's where the 0 is on the denominator. So it doesn't matter what the numerator is. As long as the denominator is 0, that means the slope is undefined. So I'm looking here. This is my slope, right? So we have this has to equal 0. So this part has to equal 0. It doesn't matter what the numerator is. It's just the bottom has to equal 0 for you have a vertical tangent line. So that would mean that 2 xy minus x to the third equals 0. So I need to solve this. What do they have in common? Yeah, they got an x. 2y minus x squared equals 0. Okay, so where would it be a point? X equals 0. And this whole thing, so 2y minus x squared equals 0, 0 product property. So set both of the parentheses equal to 0. So I'm going to solve this for y. So plus x squared. 2y equals x squared divided by 2. So when y equals x squared divided by 2, and when x equals 0. So these are the 2 points when that's the x-coordinate of each point on the curve where the tangent line is vertical. There you go. So we got this and this, and we done. Great job, everybody. Go back and check your work. Make sure you have it. And if you don't, fix it. Hit me up with any questions. Give me some text messages if you are confused. Great job.